In this lesson, we're going to discuss 4 different theorems that use similarity in some way. What's nice about these theorems is the way you solve these ones are the same way we solved in the previous lesson, which is applications of similarity. So the 4 theorems we're going to talk about is angle bisector theorem, triangle proportionality theorem, proportional segments theorem, and triangle midsegment theorem. Alright, so let's first look at angle bisector theorem. So I'm going to go over the theorem first and what it says, and then we'll do an example problem. So angle bisector theorem states that a bisector of an angle in a triangle divides the opposite side into 2 segments whose lengths are in the same ratio as the lengths of the sides adjacent to the angle. So in the picture, this is what it looks like. AD would be my bisector. The opposite side it's dividing is this part right here. It divides it into 2 segments, so BD and DC, whose lengths are in the same ratio as the lengths of the sides adjacent to the angle. So here are the sides adjacent to the angle. Okay, so in other words, this is what it means. It basically means that if AD bisects angle A, then the ratio of these sides, so BD over DC, is going to be equal to the ratio of the sides adjacent, so AB over AC. So it's basically BD over DC equals AB over AC. Okay, so applying this theorem, let's look at an example. So here's angle bisector. So the reason I know this is angle bisector is because we have our bisector here. This is the side that it's dividing, and here are the sides adjacent to the angle. So we just need to set up our ratio. Okay, so the ratio of the side opposite, we're solving for AD, so it could be 2 over x equals 3 over 6. So the way you can remember these, you kind of have to set up in the same order. So if I went from top to bottom, when I set up my other ratio, I need to go from top to bottom. If instead I went from bottom to top, I would have to go from bottom to top in the other ratio. Okay, so once it's set up, we can cross multiply 3x, and 6 times 2 is 12. Divide both sides by 3. So x equals 4. So the length of AD is 4 feet. So angle bisector theorem, the way that you can recognize the picture, so you know to apply angle bisectors, if you have a triangle and there's kind of a line going through it directly. That's how you can tell it's angle bisector theorem. Alright, the next theorem is triangle proportionality theorem. So triangle proportionality theorem states that if a line parallel to one side of the triangle intersects the other 2 sides, then it divides the 2 sides proportionally. Okay, so my parallel line here is DE, and the reason I know it's parallel is because it has arrows on it. The sides that it's dividing are these sides right here. Okay, so what this is basically saying is that if BC, and the symbol for parallel is just 2 lines like that, if BC is parallel to DE, then we know that the 2 sides are proportional. So we can set up AD over DB. And on the other side, it's going to be the same thing, AE over EC. So just like the previous one, we kind of go in the same order when setting it up. So I went from top to bottom, so my other ratio needs to be from top to bottom. Okay, so let's look at an example. So here we are. We have our parallel line in the middle, and then we have our 2 sides. So using the triangle proportionality theorem, I could set up my ratio. So I'm going to do x minus 6 over 6. so here to here, equals 2 over 3. So you need to make sure that x over 6 matches up with 2 on top, and then 6 matches up with 3. All right, now we just cross multiply. So cross multiplication here, remember we're multiplying the 3 not just by the x, but also the negative 6. So we're basically doing distributive property, so it's basically like this. So 3 times x is 3x, and then 3 times negative 6 is negative 18. And then 2 times 6 is 12. So now, using some algebra, we're going to add 18 to both sides. So 3x equals 30, and then divide by 3. So x equals 10. So triangle proportionality, the way that you can recognize triangle proportionality is if you have a triangle, just like the previous one, but the line isn't going through it this way. It's basically that you have a parallel line that's parallel to one side of the triangle. So that's how you can identify triangle proportionality. All right, the next one is proportional segments theorem. This one's very similar to triangle proportionality. The only difference is it's not a triangle, but it's still the same idea here. So if 3 parallel lines, which are going to be these ones, these are my 3 parallel lines, intersect 2 transversals, so here are my transversals, then they divide the transversals proportionally. Okay, so what that basically means is if L1 is parallel to L2, which is parallel to L3, then we know that AB over BC equals DE over EF. So when I set this one up, I went AB over BC equals DE over EF. So let's look at an example. So as you can see, this example looks really similar to this one. The only difference is that we have transversals instead of sides of a triangle, but it's essentially the same exact idea. Okay, so setting this up, applying proportional segments theorem, 2x minus 1 over 15 equals 6 over 10. Okay, now we cross multiply. So just like the previous one, we're really distributing 10 to 2x minus 1. So 10 times 2x is 20x, and 10 times negative 1 is negative 10, and then 6 times 15, which is 90. And now we can finish solving. So add 10. So 20x equals 100, and divide by 20. So x is equal to 5. So proportional segments theorem looks like triangle proportionality, but instead we basically have 2 transversals and maybe some parallel lines going across. So that's proportional segments theorem. All right, the last theorem is called triangle midsegment theorem. So before doing this, I need to define what a midsegment is. So a midsegment is the segment connecting the midpoints of 2 sides of a triangle. Okay, so this is saying the mid-segment of a triangle, which in this case is BD, is parallel to the third side of the triangle, so parallel to AE, and is half the measure of the third side of the triangle. Okay, so if it's parallel, we know that that is the case. And in symbols, kind of breaking this down, it's basically saying if B is the midpoint of AC and D is the midpoint of CE, then we know that BD is the midsegment, and the midsegment theorem basically says that BD, the midsegment, is parallel to AE, and the midsegment, which is BE, is half the measure of the side that it's parallel to. The other way you can think of it is 2 times BE, so 2 times the midsegment will give you AE. Those mean the same thing. Okay, so looking at this example, here's what we're given. We're given MNP as a triangle. It tells us that X is the midpoint of MP and Y is the midpoint of MN, which basically tells us that XY is the midsegment. So because of that, we know that XY is parallel to PN. We also know that XY is half the length of PN. So it's giving us that PN is 16. So to get XY, we basically just need to divide that by 2. So XY is 8. This also tells us that YN is 5. We want to know MY. MY, well, if Y is the midpoint and YN is 5, that means this length also has to be 5. So triangle midsegment theorem, the way that you can identify it from a picture so you know that you're applying it is obviously you have a triangle and you have a line kind of going through the middle, and the way that might be denoted is with these little symbols here. That might be what you see, and that's how you know you're going to apply triangle midsegment theorem. So this one does look like triangle proportionality theorem. The only difference is triangle proportionality theorem, it doesn't matter where this line is. This line could be in the middle, it could be towards the bottom, it could be towards the top. Triangle midsegment theorem, this line has to be the midsegment, so it has to be in the middle of this side and the middle of this side. Alright, so now let's take a look at a couple of examples. So starting with number 4, we're going to name the theorem and we're going to solve find the length indicated. So in this case, we're just solving for x. So this is angle bisector theorem. So the reason I know this is because this right here is indicating that this angle has been bisected since these angles are the same length. So using angle bisector theorem, really remember with all of these, you just need to be consistent with how you set it up. So I could do 7 over 4, and that's going to equal 14 over 2x minus 6. So 7 over 4 equals 14 over 2x minus 6. Alright, so now we cross multiply. So remember when we're cross multiplying, we're distributing 7. So 7 times 2x is 14x, and 7 times negative 6 is negative 42. And then we do 14 times 4, which is 56. And then to solve, we add 42. So 14x equals 98. And then divide both sides by 14. We get x equals 7. All right, now let's look at number 10. So here's number 10. This is going to be triangle proportionality theorem. The reason I know this is triangle proportionality theorem is because I have a line going through the triangle and that line is parallel to another one. So this one we're going to set up, I'm going to do 3 over 1 equals 6 over 2x minus 18. So remember, basically 3 and 6 have to go together and 1 and 2x minus 18 have to go together. So now we cross multiply. So we're distributing the 3, so 3 times 2x is 6x. 3 times negative 18 is negative 54. And then we have 6 times 1, which is 6. Then we add 54 to both sides. So 6x equals 60, and then divide both by 6. So x equals 10. All right, the last one I'm going to do is number 16. So this one is proportional segments theorem. So I'm going to set it up 4x minus 1 over 5 equals 12 over 4. And then we're going to cross multiply. So distributing the 4 times 4x is 16x, and 4 times negative 1 is negative 4. And then 12 times 5 is 60. So add 4 to both sides. 16x equals 64. And then divide by 16. We get x equals 4.